Okay, so what you're going to do is look at the function table. You're going to tell whether each function is quadratic. Now, how can we tell if a function table is quadratic or not? What am I looking to see?
2.
Something about a 2.
Y. Or wait.
Something with the y.
The what? What's the question?
How am I going to be able to determine if this is quadratic or not?
Set different y.
One.
Or same x's or something.
We want to make sure that the x's are not the same, and then we look at the y, and we're going to make sure that the second difference of my y numbers is what? The second difference is what? What's that key term I'm looking for?
Constant.
Constant. There we go. Okay. So we're going to look here. Are our y's the same? Or excuse me, are our x numbers the same?
Yes.
Nope.
No.
I look at my y's. I'm going to find the difference for my y's. So 1 to 4 is what? How do I go from 1?
Plus 3.
Plus 3. Then I go from 4 to 9.
Plus 5.
And then how do I get from 9 to 16?
Plus 7.
And then 16 to 25.
Plus 9.
Okay. Now, this is my first difference. Now, if all these numbers were the same my first time through, what kind of function table would it be? If they were all constant the first time through?
Then it'll just
Linear.
Linear. Good. So this is our first difference. So now we're going to go through and look at our second difference. So from 3 to 5, how do I get from 3 to 5?
8. Or plus 3.
If I have 3 plus what will get me to 5? 2. 5 plus what will get me to 7?
and then
7 plus what will get me to 9?
2.
Okay. Are these numbers, the second difference, are they all constant? Are they all the same? So is this function table quadratic?
Yes.
So we'll put yes and y. Second difference is what?
Constant. Well, it didn't say
Yeah.
to explain.
I want you to.
But that's
So we don't touch the other side?
You don't really do anything with the x's.
I don't need to do homework.
Okay. So let's look at our next table. The first thing you have to identify, are all your x's the same? No, they're all different numbers, right? So then we look at our y's. We're going to find the difference through the first time. So how do I get from -8 to -5? What am
plus 3.
+3, okay.
Then plus 3 again. Then plus 3 again. Then plus 3 again. And last but not all, plus 3 again.
Okay, so this is my first difference. Because it's my first difference and they're all constant, what kind of function is this going to be? Linear. So this is a linear,
Wait, I would say, why don't you just write down no?
so not quadratic or no quadratic.
That fancy
You like that L?
That's what I make my J's. You don't like the way
Your
I make my
cursive J's should be this.
No.
Really?
Yes.
See, I make the L then. I make an
The L is this.
That's what I make for my J's.
Yeah, your J's are wrong. You're writing Lassawa.
My
Joshua.
cursive is half print and half cursive.
Okay,
Joshua.
so because the first difference is the same, or the first difference is constant, it's linear, not quadratic. All right, let's take a look at our last example on the front side of our opener here. How do I get from -1 to 6, or excuse me, how do I get from 16 to 2?
Minus 14.
Okay, from 2 to -2,
Minus 4.
-2 to +4.
Plus 8.
Are you sure about that? Plus what?
Plus 6.
Okay, and then 4 to 20,
Plus 16.
and then
26.
20 to 46. Okay, so that's my first difference. Now let's look at my second difference. How do I get from -14 to -4?
Plus 10.
-4 to +6.
It's plus something, I know that. Plus 10.
and positive 6 to positive 16? And 16 to 26. So is this quadratic?
Yes.
Because?
Oh.
The second difference is constant.
Good. All right. So that was our front side.
Okay, back side.
Okay, you're right. Let's take a look at our back side. Just 1 second here. So flip it over. Go ahead and take a look at it if you want to. Good afternoon. Okay, so now we have equations. Are these equations quadratic? Okay, so this first equation, I have 3x to the third power minus 4x plus 5. Is that a quadratic equation?
Sure.
What power is it to?
No.
What degree?
Oh.
Oh, so it's to the third degree. For it to be quadratic, what degree does it have to be to? 2. So is it quadratic? No, because it's to the what degree?
Third.
You know I brought my science grade up, right?
Yes, that's why we're going to talk. It's not a bad talk at all. 5x squared minus 4x plus 2. Is this a quadratic equation?
Yes.
Yes, why?
Second degree.
And it's in standard form. Okay? And then we have 7x squared equals, oh, that 49 I need to fix, equals 49. An itty bitty 49.
I was wondering why that was like that.
Because
Did
she
you forget?
expects us to do it like that.
I know. I
So 7x squared equals 49.
I know what you did. You forgot when you did the exponent. You forgot to hit that arrow to go.
I did.
Past
You're
it,
right.
It kept going up.
So 7x squared equals 49. Is this going to be an example of a quadratic equation?
No.
Mm-mm.
Yeah.
Second degree.
Well,
Yes, second degree.
how could we get this written in standard form? What could I do?
7 times 7 equals 49.
Add another variable.
Well, if I want to get this 49 to this side, what do I simply do to it?
Subtract.
I subtract it, right? So then I'll have 7x squared minus 49 equals what? What's that going to equal? Nothing's over there, right? So that'll equal 0, which is okay. Now, do I have a quadratic equation?
Yes.
Yeah, it's to the second power, right? So yes, because it's second degree.
Second degree.
Okay. Moving right along. Good job. Now we're going to look at our ordered pairs. Now, when I was using the function table, which part of the ordered pair was I mostly focusing on? My x's or my y's? So I'm going to compare my y and my ordered pair. Now, an ordered pair, if you recall, is made up of an x and a y. So we're only going to focus really on our y's. So I'm going to go from my first ordered pair. What number's in the y position? What number's in the y?
4.
4. And then what's the other y I'm comparing it to?
1.
Okay. To go from 4 to 1, what am I going to have to either add or subtract to that 4 to get there?
Minus 3.
Okay. Then I'm going to go from 1 to
0.
and
-1.
minus 1.
And then 0 to 1 would be plus 1. And then 1 to 4 plus 6.
Okay. Now that's my first difference. Are my numbers constant in my first difference? Nope. Okay. So let's take a look at what my second difference will be. So -3 to -1.
Plus 2.
That's right. -1 to +1.
Plus 2.
And 1 to 3.
Plus 2.
So they're constant. So yes. Second difference, constant. Sorry, I know that's a little sloppy looking. Okay, ready for the last one? What am I comparing? What am I looking at? What am I trying to find the difference of? It's a better question.
6.
and,
3 to
okay, 6 and 3. So what's that going to be?
3.
Negative
Okay, and then 3 to 2.
2. Negative 2.
Say it again.
Negative 2.
Say it again.
Negative 2.
I disagree.
-1.
Negative 1.
Aw.
Okay, 2 to 3.
Negative 1. Or plus 1.
So 6 to 3 minus 3. 3 to 2 we minus 1. 2 to, okay, so we plus 1. And then 3 to 6.
Plus 3. So it's the same as last time. And it's going to be plus 2, plus 2, plus 2.
You agree?
Yeah.
You guys all sure you agree with him?
Yeah.
No.
I do. So is it quadratic?
Yes.
And why?
Because the second difference is constant.
Do you guys understand what I'm trying to get you to say now?
I
Second
disagreed.
difference is
I still
constant.
have
Yeah, I
it.
want you to know.
I disagreed. I already had it written down that it was.
Okay.
Can we just write down yes? The second. Can we just do like
I
second
put
difference?
You can abbreviate it just like me. Now hold on, before you collect these, let's look at something.
Can we just write down second? Yes, second difference.
What about it? What about the second? Is the same? Is different? Is what? I don't know. You got to tell me.
I don't want it.
Well, that's problematic then. Okay. We're going to get rid of that. We're going to come to this.
Yeah, I'm pretty sure.
I just want a basic.
Wait, we already finished these.
Yeah, we just finished it.
No, I know, guys. I'm trying to get a piece of paper.
For each of these in, right?
Okay. Part of my drawing, I am not the best drawer. I am not a very good artist.
No.
I think we've talked about this before.
I know a good way to do that line. Do you know how the best thing to do it is?
To use my line thing
No.
on my graph.
What I do is I make dots, make like line segments, like kind of like line
A
dashes.
dotted line.
Dotted line. Thank you. Dotted line down like a certain number, and then over a certain number, then over a certain number,
Here.
they're on the same number.
There. How's that?
That works.
It's a little uneven.
Hey.
Yeah, it bothers me.
Hey.
It bothers me.
I think it
It is
was
a-
perfect.
Okay, thanks, Dylan. All right. Label my coordinate plane. The line that is vertical is called what?
Y-axis.
X.
It's the
Vertical. Vertical's up and down.
Y.
Okay.
Why is Y?
Because it's got the long thing.
And what is my horizontal?
X-axis.
You want to know why it's called the x-axis too?
What is this area called?
The origin.
The origin.
Or 0.
Okay.
Or root.
Okay. Again, part of my drawing. What kind of line is this called? Parabola. And what's a parabola?
It's quadratic.
What kind of line do we graph when we graph a parabola when we're graphing a what?
Quadratic.
Quadratic, okay? The bottom of a parabola is called, or where
Vertex.
where it's at the very bottom, that's called the vertex. Now, based on where the vertex is, it could either be what two words?
The minimum or maximum.
Because it's the lowest, it's the, because my vertex is the
It's
lowest.
Vertex minimum.
Okay,
Wait, is it alright to put down min? That's what I did on my homework.
okay, yeah, that's fine. Okay, what is,
The y-intercept.
okay, so it can be the y-intercept, because it's where the
That's the
line
x-intercept.
goes through the y-axis, or excuse me, the x-intercept, because it's where the line goes through the x-axis. But what else is it called, you guys? There's 3 other names that you could call your x-intercept.
Zone 0. Sorry, root 0. Does it start with an S?
It does start with an S. Not substitution.
Substitute.
Not substance. Roots,
Solution.
zeros, solution. Good.
Smartness. Big brain.
My son's been saying that lately too.
What? Big brain?
Okay. What does this represent on my graph?
Y-intercept?
Yeah. Is Nick the only one that knows this?
Yes, because Nick has a big brain.
Okay. And then my last thing I want to ask about. What is that
You
called?
know what? I won't answer this one.
Oh, really?
What is it called? Nope.
Okay, where are we?
That
Yep.
dotted line that goes, imagine, it goes right in the middle of that parabola.
I thought Robert said it for text
Oh,
maximum.
No.
that's
You said no.
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 Hold on.
Nah.
We got
I like Lucas is getting his notes out.
Lucas has.
I think Kata might know it. No?
I wasn't paying attention.
Oh my goodness.
That makes sense.
we have an honest individual over there.
Right? It is.
It's good to have at least one.
Beat him, Lucas.
Axis.
No, what?
Symmetry.
Yes.
Oh, I got it right.
Axis of
I
symmetry.
got it right.
Looking at your notes, did I miss any terms?
Yes. Nick.
I am missing the maximum. Why can't I have a maximum?
Because it's not.
'Cause
This
it's-
thing's not flipped.
Now, if it was flipped like the arch, then I would have a maximum, but I wouldn't have a minimum. All right. Nice job.
Nick